Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this problem. So let's get started. Alright, let's see this problem. In this problem we are given an array and our task is to find maximum circular subarray sum. Meaning we have to find the maximum sum of circular subarray. So let's first understand what does it mean by circular subarray. So let's say we have an array like this 1, -2, 3, 4. And these are the possible subarrays formed by these arrays. And these subarrays are 1, -2, 3, 4, 1, -2, -2, 3, so on and so forth. So these are the normal subarrays and we already know about it. Moving on to circular subarray. So when we connect the first element of the array to the last element of the array, it forms circular subarray. Like this. Here I have connected the first element, that is 1, with the 4. So it forms the circular subarray. Now if I ask you how many circular subarrays are possible, then it could be -2, 3, 4, 1. Starting from -2, 3 and 4 and 1. Then 3, 4, 1. Then 3, 4, 1, -2. 4 and 1. 4, 1, -2 and 4, 1, -2, 3. So these are all the possible circular subarray formed with this array. And in this problem, we have to find maximum sum of circular subarray. It includes normal subarray also and circular subarray also. So let's understand this problem with few examples. Let's see this first example. Here we have an array like 1, -2, 3 and 4. And the maximum sum of circular subarray is 8. And it is formed by adding the elements 3, 4 and 1. Okay, let's see the next example. In this example we have an array -2, 7, 3 and -4. In this example maximum sum of circular subarray is 10 and it is formed by these two elements 7 and 3. And if you see the sum of other circular subarray, let's say -4 and -2, you get -6, that is less than 10. Okay, let's see this example. Here we have an array -4, 2 and 5. And in this array the maximum circular subarray sum is 7 and that is formed by two elements, that is 2 and 5. In next example, here we have an array like 1, 3 and -4. And here the maximum circular subarray sum is 4 and that is formed by elements 1 and 3. So to solve this problem, you have to consider the normal subarray and the circular subarray and find the maximum circular subarray sum. So I hope now you understand this problem really well. So let's pause the video and think about an algorithm to solve this problem. Alright, I hope by now you would have at least written basic program to solve this problem. So now let's see the brute force approach to solve this problem. The idea of brute force approach is simple. Traverse an array from left to right and find all the subarrays including circular subarray beginning with the current element. And while traversing, keep track of maximum sum we have seen so far. So this is the basic idea. Now let's see the implementation of this basic approach. Here we have a maximum circular subarray sum and this function is taking arrays input. In first statement we are getting the length of array. In next statement we are initializing a variable maximum so far to 0. And then we are running a loop from I equal to 0 till I less than n. Okay. And then we are initializing two variables, current maximum and total sum. Let's understand what is the use of these two variables. So the current maximum variable keep track of the current maximum we have seen so far. So what happens when we consider element 1, that is 1, and we find all these subarrays beginning with this element. So in each iteration we keep track of the maximum sum we have seen so far. Okay, and the second element total sum simply keep track of sum of all the elements of the subarray. Okay. So after this we are again running a loop from j equal to 1 till j less than n. Okay. And then we are finding index using modular arithmetic. let me tell you the reason why we are using here modular arithmetic and why we are running this loop from 1. Okay, so let's say the value of I is equal to 0 and value of j is 1. So 0 plus 1 is equal to 1, 1 plus 1 is equal to 2, 2 plus 1 is equal to 3, 3 plus 1 equal to 4. But here we have to also consider the circular subarray. So we have to go beyond this index and again start counting from 1 to 3, right? So that is why we have used the modular arithmetic here. So what happens when I becomes 2 and value of j starts from 1? So 2 plus 1 is going to be 3, then 2 plus 2 is going to be 4, and we are doing modulus with 4. So it gives us 0 index. So after third index, we are again going to 0 index. And then 3 plus 2 is equal to 5, modulus 4, it gives 1, and then we are going to index 1. So this is how we consider the circular subarray of this given array. So I hope now you understand that why we are using I plus j mod n here to get the index of the circular subarray. Okay, so far so clear. And after getting the index, we are adding the value of that particular index in total sum. And at the same time, we are finding the current maximum we have seen so far. And after loop gets completed, again we are comparing the current max with the maximum so far. And this is our global maximum so far, not for the specific subarray beginning with an element. And if we found that the current maximum is greater than maximum so far, we immediately update the maximum so far to current maximum. And after the outer loop, we simply return the value of maximum so far. So this is all about this function. Now let's quickly dive into this function and see how it works. So let's say we have an array like this, 1, minus 2, 3, 4. Okay, we initialize maximum so far to 0 and the value of n is 4. So our loop begins and the value of I initially is 0. We initialize current maximum to 1 and total sum is 1 because the value present at index 0 is 1, right? And we begin the inner loop from j equal to 1. So it checks for index 1, right? Because the value present at 0 index is already stored in the current maximum and total sum. Okay. So we have to traverse from the next index obviously. So it's going to add value present at index 1, that is minus 2. So 1 minus 2 is going to be minus 1. Then it's going to add 3 to it. Minus 1 plus 3 is equal to 2 and 2 plus 4 is equal to 6. So we get the current maximum as 6. Okay. So after loop gets completed, we compare current maximum with maximum so far and we found a new maximum. So we update the maximum so far to 6. Okay. And the outer loop moves to next iteration. In next iteration, the value of I becomes 1. We again initialize the CM and TS with the element present at index 2, that is minus 2 now. And we start traversing from the next element, that is index 2. So we check for index 2, then we check for 3 and then 1 and we add all the values in total sum. And we found current maximum as 4, that is not greater than maximum so far. So we keep maximum so far as it is. So in this loop, we are considering minus 2, 3, 4 and 1. Okay. Moving to next iteration. In next iteration, our I becomes 2 and we store the value present at index 2 into current maximum and total sum, that is 3. And we consider all this subarray beginning with this number, that is 3, 4, 3, 4, 1 and 3, 4, 1 minus 2. And the maximum we get is 8. So we get the maximum that is greater than maximum so far. So we update the maximum so far to 8. In next iteration, the value of I becomes 3. We store the value present at index 3 into current maximum and total sum, that is 4. And we check for all these subarrays beginning with 4. I mean all these circular subarrays. So 4, we consider 4 and 1. Then we consider 4, 1 and minus 2. Then we consider 4, minus 2 and 3. This way the current maximum comes out to be 6. That is not greater than maximum so far. So we keep the maximum so far as 8. So after fourth iteration, our loop gets completed and we come out of the loop. And the output of this input is going to be 8. It means 8 is the maximum circular Subarray sum, and that is formed by these 3 elements 3, 4 and 1. 4 plus 3, 7, and 7 plus 1 is 8. So far so clear. So now talking about the time complexity of this function. As we are running 2 loops, outer loop is running n times, and in worst case our inner loop also runs n times. So we can say that the time complexity of this function is going to be big of n square. Talking about the space complexity, as we are not using any extra space other than few variables, then we can say that the space complexity of this function is going to be theta of 1. So basically with this approach, we are solving this problem in big of n square time complexity and using constant space. But here we are not satisfied with the algorithm because it is taking n square, and that is quadratic order of growth. So can we do it better? Can we reduce the iteration? Can we solve it in big of n time complexity? Can we use the cadence algorithm to solve this problem? So ask all of these questions to yourself and observe the given array once again and think about a solution that can solve this problem in big of n time complexity. Alright, let's see the efficient approach to solve this problem. So we are given an array 1, minus 2, 3 and 4. These are the elements of the array. The idea is pretty simple. First we have to find the maximum subarray sum using the cadence algorithm, and then we will find the maximum subarray sum of circular subarray, and then we simply have to return the maximum of both. This is the basic idea. Now the question arises that how to find the circular subarray sum. So let's see how we find it. So let's say we have an array like this 1, minus 2, 3 and 4. This is the same array we have been using. If you look at this array carefully, you will see that the maximum circular subarray sum is produced by adding 3, 4 and 1 elements. Okay, and the minimum subarray sum of this array is minus 2. So what if we find sum of all the elements and subtract this element from it? We get the circular subarray sum, right? And this is logical. So what we do, we simply find the sum of total elements of this array and we simply subtract the minimum subarray sum from the total sum to get the maximum circular subarray sum. Okay, so far so clear. Now the next question arises that how to find minimum subarray sum. So we have an array 1, minus 2, 3, 4 and we also know cadence algorithm to find the maximum subarray sum. So can we use the same algorithm to find the minimum subarray sum? Yes, definitely we can use the same algorithm. We do not have to write new algorithm for it. So let's see how we use the same algorithm to find the minimum subarray sum. So what we do to find the minimum subarray sum, we simply invert the sign of all the elements and then we call the cadence algorithm on this array. So this way our cadence algorithm on this array, the cadence algorithm gives the maximum subarray sum that is equal to 2 because this is the only positive element present in this array. Else other elements are negative because we have already inverted the sign of all the elements. So we get the maximum subarray sum. Now the last step is we have to subtract this number from total sum. But you can see that here we are doing addition instead of subtraction. Why is like that? The reason is pretty simple. If we had not inverted all the signs of the number, then we would be expecting minus 2, right? And when we get minus 2, we are doing total minus minus 2. So minus minus become plus. So this is the same thing we are doing here also. So instead of negative number, here we are getting positive number. That is why we have removed the negative sign with the plus sign. And also as we have inverted signs of all the numbers here, so we should be inverting the sign of this expression also. So after adding total sum plus minimum subarray sum, we get 8. And this is the maximum circular subarray sum possible in this array. So this is the idea we are using to solve this problem. Now let's see the implementation of this approach. Here we have a function maximum circular subarray sum and this function is taking an array And in the first step, what we are doing, we are using the same cadence algorithm to find the normal subarray sum. Okay. Then we are checking if normal subarray sum is less than 0 or not. If it is 0, then we simply return normal subarray sum. So I will explain this piece of code in a bit. After this, we are initializing a variable total sum is equal to 0 to find the total sum of the array, and along with we are also inverting the sign of all the elements. And after this for loop, what we are doing, we are again passing this array to maximum sum array to find the minimum sum array and adding it to the total sum array. And after this step, we are comparing normal subarray with the circular subarray and returning the maximum of both. So this is how this function is going to work. And here this is the same cadence algorithm we have used so far. Now talking about this condition, normal subarray less than or equal to 0, why we are doing this? So let's say we have an array like this, -1, -2 and -3. And if we found the maximum subarray, it gives -1. Okay. And if we not check this condition, then what happens? It's going to count the total sum, that is going to be -3 plus 2, 4, 5 and -6. And then it's going to invert sign of all the numbers from negative to positive, 1, 2 and 3. And then it's going to find the maximum. So maximum is going to be 3, 4, 5, 6. And then we are doing total plus maximum. The total is going to be 6 plus -6. So it will cancel out each other and it gives 0 as the output, and that is going to be the wrong output as per this array. So to prevent this condition, we are checking if the normal subarray sum is less than 0, then simply return normal subarray sum. And this is going to be the maximum circular subarray sum of this given array. So let's quickly try run this code and see how it works. So we have an array 1, -2, 3, 4. In first step, we find the normal subarray sum, and that comes out to be 7. Okay. And then we are going to compute total sum of all the elements, and that comes out to be 6. So while computing total sum, we are inverting the sign of all the numbers, and then we are simply calling max subarray sum for that particular array. Okay. So it comes out to be 2, and we are simply adding with total sum to get the maximum circular subarray sum, that is 8. So the output of this function for this particular input is going to be 8, and this is the maximum circular subarray sum we have seen so far. So far so good. Now talking about the time complexity, we are running loop n times for calculating maximum subarray sum. Then again we are running loop n times to compute the total sum and inverting all the sign. And again here we are calling the loop, we are calling this function and running loop n times. So we are exactly running loop 3n times. So we can say that the time complexity of this function comes out to be theta n. And talking about the space complexity, as we are not using any extra space, so the space complexity comes out to be theta of 1. Okay, so this efficient approach took theta of n time and theta of 1 constant space to solve this problem. So before we end this video, let's have a quick recap of what we have done so far. So we were given a problem, and in this problem we were given an array, and our task was to find the maximum circular subarray sum. We saw the brute force approach to solve this problem, and in this approach the time complexity came out to be big of n square. After brute force approach, we saw the efficient approach to solve this problem, and in this approach we have used cadence algorithm, and using this approach the time complexity came out to be big of n. So we have successfully reduced the time complexity from quadratic order of growth to linear order of growth. So I hope now you understand this problem really well, and now you know how to find maximum circular subarray sum. So this is it for this video. Thanks for watching, and see you in the next video.